Okay, continuing with the previous part, we had discussed about the input equation, which is given by x dot of t is equal to ax of t plus b u of t, where u of t represents the input. If I make the input go 0, my equation reduces to x dot of t is equal to a into x of d, which is termed as homogeneous equation. The solution for homogeneous equation is given by x of t is equal to e to the power at to x of 0. If I consider the whole equation with my inputs applied, then it is called as non-homogeneous equation, and the solution for that is given by x of t is equal to e to the power at into x of 0 plus integral 0 to t e to the power a of t minus tau, okay, t minus tau into b u of tau into d tau, where this first part e to the power at x of 0 is termed as ZIR. ZIR means 0 input response. This is with respect to me making input go to 0. This is called as ZSR, means 0 state response. Okay. So, the solution for non-homogeneous equation will be ZIR plus ZSR. Okay. So, 0 input response and 0 state response. We need to know some properties before we go to solve the problem. What are the properties? And before going to the properties also, let me tell you, e to the power at is given by Laplace inverse of Si minus A whole inverse. Okay, this is nothing but your phi of t or e to the power at. This is one formula what you are supposed to know, where e to the power at is the response of a system. Now, let us see some properties of your state, and this e to the power at is called as state transition matrix, which is defined by Laplace inverse of Si minus A whole inverse. What are the properties? Okay, this is one important question in the examination, wherein he will ask you to list the properties. As I told you, phi of t is equal to e to the power at, that is called as state transition matrix. If my t is at 0, this becomes e to the power a into t e to the power 0, that is 1, that is called as identity matrix. If at some time t, okay, I can rewrite my e to the power at as e to the power minus at into minus, okay, minus becomes plus, so there is no change. That will be written as, we all know e to the power at is phi of t, so e to the power minus at will be phi of minus t whole inverse. Okay, same way, if it is phi of t1 plus t2, that will become e to the power a into t1 plus t2, that can be split into e to the power at1 into e to the power at2. If it is e to the power a into t of s, you can multiply these terms, so it will be e to the power at into e to the power s. This is like your indices, rules or properties of indices, where the bases are same, I can add the powers. Same thing applied here for my state transition matrix. E to the power a plus b into t will be again written as e to the power at plus into e to the power bt. Condition is a into b should always be equal to b into a. If these two are not equal, then this property is not applicable. Next, phi of t whole to the power n is equal to, phi of t is nothing but e to the power of t, e to the power n, that becomes e to the power a into t, or e to the power a into t is nothing but phi of nt. The last property, phi of t1 minus tt into phi of t1 minus t0 is equal to t1, if I open t1 gets cancelled, phi of t2 minus 0, where t1, since these two are common, I can take t2 minus t0, that will be my final state transition. Okay, with these properties in mind, let us try to solve some problems. Let me take one problem now. The problem is, find the state transition matrix for, okay, A is equal to 0 plus 2 and minus 1 minus 3. Very important question, asked many times in the examination, 8 marks question. Okay, he is asking you to find state transition matrix. What is my state transition matrix? E to the power at is equal to Laplace inverse of Si minus A whole inverse, right? A is given. I am supposed to find out Si minus A. So first let me find out Si minus A, that is equal to S into, since this is a 2 by 2 matrix, I will also be 2 by 2 matrix, where it will be identity. I means identity matrix 1 0 0 1 minus, what is my A? 0 2 minus 1 minus 3. This will be equal to, you all know how to do this. This will become S minus 0, that is S. This will be 0, then minus 2, so this will be minus 2 plus 1 and S plus 3. Okay. Next I am supposed to find out Si minus A inverse. How do I find Si minus A inverse? Si minus A inverse is equal to adjoint Si minus A divided by determinant Si minus A. Correct? How do I find adjoint Si minus A? Adjoint Si minus A is equal to, first I should find the transpose. So it will be my Si minus A, that is S minus 2, S minus 2, sorry, I am supposed to take the transpose, S plus 1 and then 2 and yes, this becomes minus 1, 2 and S transpose, that is nothing but S plus 3 minus 1 2 into S. I am supposed to take the cofactor, and then after taking the cofactor, whatever matrix I get, that transpose will give me my adjoint Si minus A. Okay. So now what is my determinant Si minus A? Determinant Si minus A will be S minus 2 1 S plus 3, open the bracket, what do you get? S square plus 3S plus 2, that is nothing but S plus 1 into S plus 2. Okay. Next, what is my Si minus A inverse? What is my Si minus A whole inverse? That is nothing but, I know my adjoint S, I am going to substitute adjoint Si minus A divided by determinant Si minus A, wherein my adjoint Si minus A, I know the matrix. What is the matrix? From previous calculation, S plus 3 2 minus 1 and S whole divided by, I know what is determinant Si minus A, that is S plus 1 into S plus 2. This whole can be written as S plus 3 divided by, this is the common denominator for all the terms in this matrix. So S plus 3 divided by S plus 1 into S plus 2 minus 1 divided by S plus 1 into S plus 2, and here it is 2 divided by S plus 1 into S plus 2, and here it is S divided by S plus 1 into S plus 2. Okay, you understood this? Now I am supposed to take the Laplace inverse. Laplace inverse of this. You need to know two formulas for Laplace inverse, specially, that is important formulas. First one, Laplace inverse of 1 by S plus A is equal to e to the power minus at. Second one, Laplace inverse of 1 by S minus A is equal to e to the power at. These two are normally used here. So what we do is, I am going to use it here, find the Laplace inverse for this. See, this when compared, before this what I am supposed to do is, I am supposed to take the partial fraction. Each one, I am going to take each term in this matrix and I am going to find the partial fraction. Partial fraction, you all know how to find it, do it separately for each one. Okay, it is not clubbed here. this separate, this separate, this separate, this separate. Then my whole matrix reduces to e to the power at is equal to Laplace inverse of 2 by s plus 1 minus 1 by s plus 2. That is for this term. Next term, it is 2 by s plus 1 minus 2 by s plus 2. That is for this term. Same way for this one, it will be minus 1 by s plus 1 plus 1 by s plus 2. Here it will be minus 1 by s plus 1 plus 2 by s plus 2. Now I am going to apply these formulas. See this, compare this with this. So this is of the form 1 by s plus a. So it will be e to the power minus at. What is a? A will be my 2. Okay, so 2 I will keep it as it. So it is e to the power at is equal to, this term will be 2 into this 2 as it is. So if I take 2, it will be 1 by s plus 1. 1 by s plus 1 will be e to the power minus at, that is e to the power minus t. Minus, this is 1 by s plus 2. So it is e to the power minus 2t. Okay. Next, minus 1 by s plus 1. So it will be minus e to the power minus t, and this will be plus 1 by s plus 2 will be e to the power minus 2t. Same way 2 by s plus 1 will be 2 to the power e to the power minus t as per this formula, and this formula minus 2 to the power 2 into e to the power minus 2t. This will be minus 1 by s plus 1 will be e to the power minus e to the power minus t plus 2 e to the power minus 2t. This is nothing but your state transition matrix given by phi of t.